Good morning, students. So, in the last class, we were discussing about the chapter polymers. Okay. So, what all we have discussed in polymers. So, we'll just have a glance. Okay. So, we have discussed what are polymers, right? We have seen what is the classification of polymers. The first classification was based on the origin, right? So they are classified as natural polymers, synthetic polymers, and semi-synthetic polymers. We have seen the definition and the examples. Then we have seen the second classification that is based on structure. So based on structure, they are classified as linear polymers, branch-chain polymers, and cross-linked polymers. So we have discussed about this also. We have seen the examples also. The third classification is based on the type of monomers. Okay, so they are classified as homopolymers and copolymers. Okay, we have seen this. Next, we have discussed about based on the modes of synthesis or polymerization. They are classified as addition polymers and condensation polymers. Okay, then we have seen based on the molecular forces, elastomers, fibers, okay, thermoplastics, thermosetting polymers. So this we have all discussed. So we were discussing about some of the important polymers. So we were here. Okay, so here we are going to discuss about some of the important polymers. So what are the important polymers? We are going to see which is the monomer, okay, involved in that, and what type of polymerization it takes place, right? So polythene, the monomer is ethene. Okay, and the type of polymerization it undergoes is the addition polymerization. Then, so you can see the structure of ethene. So ethene is a very need to know which is the monomer present or which is used to build up the polymer. The second is propylene, polypropylene. So the monomer used is propene. Okay, the type of polymerization it undergoes is a addition polymerization, right? So we have discussed about what is addition polymerization, what is condensation polymerization, right? So next is Teflon, okay, or tetrafluoroethene. So the tetrafluoroethene is the monomer. So you can see the structure of tetrafluoroethene. So this undergoes a chain growth homopolymer. Okay. Then the next is polyacrylonitrile. So it is also called as Orlon. Okay. That is PAN. The abbreviated as PAN. So the monomer used is acrylonitrile. So you can see the structure of acrylonitrile. So acrylonitrile. So whatever addition it undergoes a addition homopolymer. Undergoes a addition homopolymer. Next. So here what is important is that you need to know the monomer which is present and what type of polymer it forms. Okay. So this is very important here. The things you need to know. Next is polyvinyl chloride. That is, it is abbreviated as PVC. Okay, so the monomer used is vinyl chloride. So which is the monomer? It is vinyl chloride. Okay, so what type of polymerization it undergoes? It undergoes a chain growth homopolymer. It undergoes a chain growth homopolymer. Then sixth one is polystyrene. The monomer is styrene. Okay, so this is the structure of styrene. So this is a structure of styrene. So it undergoes what? It undergoes a addition homopolymerization. So here a benzene ring is involved. Okay. Here you can see the structure. So CH2 double bond CH. Okay, this is attached to a C6H5 is nothing but your benzene ring. Okay, so this is styrene. So this is styrene. So it undergoes a addition homopolymerization. Next is polymethyl methacrylate. That is PMMA. Okay, so the structure of methyl methacrylate is this. So what type of polymerization it undergoes? It undergoes a addition homopolymer. Okay. Next is natural rubber. So the this is very important. So which is a monomer? It is isoprene. Okay, please remember this important asked. What is the type of polymerization it undergoes? It undergoes a addition homopolymer. Okay. Next is neoprene. So neoprene is a synthetic rubber. It is called as what? It is called as a synthetic rubber. Okay, it is a synthetic rubber. Okay, so or it is called as the artificial rubber. Okay, it is a man-made rubber. So neoprene. Okay, so which is the monomer? It is chloroprene. So here, so to this Cl is attached. Okay, chloroprene. So it is a chloroprene structure. Okay, so this is a chloroprene structure. So what type of polymerization it undergoes? It undergoes a addition homopolymerization. Next is your Buna S. Okay, Buna S means Buna represents your butadiene. Okay, Buna represents your butadiene and styrene. S means styrene. So butadiene. So the two isomers which are present or two monomers which are present in Buna S is 1,3-butadiene and styrene. So it undergoes a copolymerization. What do you mean by copolymerization? So whenever you need to build up a polymer, so if there are two or more different monomers used, then it undergoes a copolymerization. Okay, so co means many, two or more monomers are used. Okay, so here 1,3-butadiene and styrene is used. What is Buna N? Buna is 1,3-butadiene and N is acrylonitrile. So this also undergoes a addition of polymer. So please remember the monomers which are used to build up the polymer. So very important. Next is nylon 6,6. So nylon 6,6 is an example of polyamide. Okay, amide is what? C double bond to NH. So it has a amide linkage. Okay, it has a amide linkage in nylon 6,6. So which are the which are the monomer used here? So the monomer uses hexamethylene diamine. Okay, the monomer uses hexamethylene diamine and adipic acid. So please remember the structures also and the your monomers also. Okay, so there are two different monomers. So when two or more different monomers are there, it undergoes a copolymerization and it undergoes a condensation reaction. What do you mean by condensation reaction? Okay, when they have bifunctional or trifunctional groups are there, with the it undergoes a addition of bifunctional or trifunctional group. Okay, with the elimination of small molecules. Okay, so it shows a copolymerization condensation. Okay, next is terylene or decron. So next is what? Terylene or decron. So it is a polyester. So it has a ester linkage. Okay, next is a ester linkage. So this is a ester linkage. So whenever there is a ester linkage, so which are the monomer which is used? It is ethylene glycol and benzene 1,4-dicarboxylic acid, or it is called as terephthalic acid. Okay, so the condensation it undergoes is a copolymer condensation. Okay, so these are the polymers and monomers. Please remember the monomers. Next polymer is polyhydroxybutyrate. Okay, next is what? Polyhydroxybutyrate, that is PHP. PHP. So the monomer used is 3-hydroxybutanoic acid. Okay, 3-hydroxybutanoic acid. The type of polymer is condensation homopolymer. Okay, so the type of condensation is what? It is a uh, it is a condensation homopolymer. So only one type of polymer is involved. Next is urea formaldehyde resin. So the monomer used is formaldehyde and urea. So what type polymer it forms? It forms a copolymer. Okay, it forms a copolymer. Copolymer means because there are two different monomers involved in making this urea formaldehyde resin. Okay, next is bakelite. So next is what? Bakelite. So the monomer uses formaldehyde plus phenol. So which is the monomer? That is formaldehyde plus phenol. Okay. So what is the type of polymer used is step growth thermosetting polymer. Okay, so step growth thermosetting polymer. So we know about thermosetting polymer. Yes, what do you mean by thermosetting polymer? So we have seen about the thermosetting polymer, right? So it comes in based on molecular forces, right? So thermosetting means what? Thermosetting means they do not soften on heating, instead they become very hard. Okay, so thus they are called as thermosetting polymers. Okay, So which we were seeing was, so that is step growth. Okay, step growth thermosetting polymer. Next is glyptal. So polymer is a glyptal. So which is a monomer ethylene glycol and phthalic acid. So this is a thermoplastic polymer. So thermoplastic polymer is what? So thermoplastic polymer means what? That is it softens on heating. Okay, when you heat it, it gets softened, and when you cool it, it becomes hard. Okay, so this is the nature of thermoplastic. So this is an example of thermoplastic polymer. Next is your, okay, next is nylon 6. Okay, so next is your nylon 6. So nylon 6, the monomer is caprolactam. What it is? It is a caprolactam. Okay, so what type of polymer it is? So it is a homopolymer. Okay, what type of polymer it is? It is a homopolymer. Okay. Next is the last one. It is polyhydroxy butyrate cohydroxyvalerate. Okay, so this is the important. So you need to know what is the monomer. So it is PHBV. Okay, PHBV. So it is a polymer. Okay, it is a polymer. So it is abbreviated as PHBV. That is polyhydroxy butyrate. Okay, cohydroxyvalerate. Okay, so which is the monomer present? It is 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. So what is the type of polymer? It is a condensation copolymer. Okay, so these were some of the polymers, and which so the monomers what are present in this, and we have seen what type of polymerization it undergoes. Okay, so we have seen, so depending upon the type of polymerization, type of monomer which is present in that. Okay, so this type of polymerization is what you can say, it is classified. Okay, so some of them undergoes a chain growth polymerization, some of them undergoes homopolymerization, some undergoes copolymer condensation, right? So these are some of the various polymerization these polymers take. Okay, so I hope this is clear. Okay, so here the important things what you need to remember are the definitions. Then you need to remember what type of examples they cover, and you need to remember the polymer, okay, and their monomers, and what type of polymerization it undergoes, uh, what type of bond it is present. Okay, suppose in nylon 6,6, the nylon 6,6 is called as what? It is called as a polyamide. Why? Because it consists of amide linkage. So like this, so they are classified based on the type of functional group it has. Okay, so you need to know the monomer what is present in that. So like this, you need to remember the things. So I hope this session is clear. Yes, so now based on this your polymer chapter, so we'll solve some questions. Yes, so it's 2 minutes. Okay, so here are some of the questions which we need to solve. Okay, so these are some of the questions which we need to solve from the chapter polymers. Okay, so based on the concepts which I hope is clear. Okay, so okay. So the first question is, so which of the following polymers is prepared by addition polymerization? Okay, so you have to answer which among the following is prepared by addition polymerization. You know what is addition polymerization now, right? So which one will go addition polymerization? So this was a question asked in NEET 2021. Okay, so the options are A, Dacron, Okay, B Teflon, C nylon 66, and D Novella. So try to answer the question. So which among the following, which polymer is prepared by addition polymerization? Yes. So before that, what do you mean by addition polymerization? So addition polymerization is also called as what? It is also called as chain growth polymerization, right? So here what will happen? The molecules of the same monomer or different monomer, okay, they will add up, right? They will add up to give you a large molecule. Okay, large molecule. So what will happen? There will be increase in the chain length or chain growth. So this is called a chain growth polymerization. So right, so this is a addition polymerization. So now you have to tell me, so these are the options. So you have to tell me which will which can be prepared by a chain growth polymerization. Yes, try to answer it. Okay, so here the chain growth, okay, so it should be between the, so here Dacron, okay, Dacron. Next is what? Teflon, then nylon 66 and Noveloc. Okay, so which of this is called is used for addition polymerization? So nylon 66. Okay, first we'll go with nylon 66. So what is nylon 66? Nylon 66, it consists of hexamethylene diamine and adipic acid. Okay, it undergoes a condensation reaction because the both are bifunctional group. So both the monomers are containing the bifunctional group. So first option is discarded. Sorry, yeah, C1. Next is uh, Decron. Okay, A options. We'll see the A option, that is Decron. Decron is also called as stearinine. Okay, so here also what is present? The monomers are ethylene glycol and terephthalic acid. Okay, so one is alcohol, another is a acid. So ester linkage is present, right? So this also will undergo a condensation reaction. Next is Novaloc. Novaloc. Okay. So in Novaloc, what is present? In Novaloc, what is present? Yes, in Novaloc. So in Novaloc, what is present in Novaloc? Phenol and formaldehyde is present. Okay, phenol and formaldehyde is present. So there are two different what you can say monomers. So this also will undergo a copolymerization, right? So they have asked what is addition polymerization. So in Teflon, okay, so option C, D is also discarded. So option D is also discarded. So Teflon, okay, to produce a Teflon, so what is used to produce Teflon? Okay, to produce this Teflon, which is the monomer which is used? It is tetrafluoroethene, right? It is tetrafluoroethene. So tetrafluoroethene, it is used for preparing your Teflon. So tetrafluoroethene. So tetrafluoroethene, TFE. Okay, tetrafluoroethene. So tetrafluoroethene is used. So that is CF2 double bond CF2. So this is used to produce. Okay, so N number. So like this. So this is the polymer. So A. It undergoes a addition reaction, polymerization. We'll go for the next question. Which of the following is a natural polymer? Okay, which among the following is a natural polymer? A. Cis 1,4 polyisoprene. B. Polybutadiene styrene. C. Polybutadiene. D. Polybutadiene acrylonitrile. So which among the following? So this was a question asked in NEET 2020. So which is the following a natural polymer? It is A. Okay, it is A. So natural polymer is natural rubber. It is made up of cis 1,4 polyisoprene. Okay, it is made up of cis so isoprene, that is CH2 double bond CH C CH3 and double bond CH2. So isoprene. Okay, so this is isoprene. So it is a natural polymer. So answer is A. R- Rest all are synthetic. Next is the polymer that is used as a substitute for wool in making commercial fibers is okay. A. Melamine. B. Nylon 66. C. Polyacrylonitrile and D. Buna N. Yes, which is used as a substitute. Which polymer? It is C. Okay, it is C. What is the answer? It is C. It is C. So polyacrylonitrile. Okay, it is used as a substitute for wool in making commercial fibers. Okay, option number C, that is polyacrylonitrile. So remember this. We'll go for the next one. Regarding cross-linked, okay, regarding cross-linked or network polymers, which of the following statements is incorrect? So A, they contain covalent bonds between various linear polymer chains. B, they are formed from bifunctional and trifunctional monomers. C, examples are bakelite and melamine. And D, they contain strong covalent bonds in their polymer chain. So this was a question asked in NEET 2018. Okay, so which is regarding cross-linked or network polymers, okay, which is a wrong statement. Fine. So cross-linked or network polymers are usually formed from bifunctional and trifunctional monomers. Okay. So how these cross-linked are formed? So they are formed from bifunctional and trifunctional monomers. And also they contain strong covalent bonds. Okay. Between various linear polymer chains like melamine and bakelite. Okay, so the statement which is wrong is okay D. They contain strong covalent bond in their polymer chains. Okay, so option number four. So option number four is the incorrect statement. Okay, so we'll go for the next question. Which of the following structures represents nylon 66 polymer? Yes. So how is nylon 66 formed? So nylon 66 is formed from monomers like adipic acid and hexamethylene diamine. So adipic acid is COOH. Okay. CH2 four times and COH. So this is adipic acid and hexamethylene diamine is NH2, then CH2 6 and NH2. Okay, so this is hexamethylene diamine. Okay, so these are the polymer which is formed here is what? Option number D. Okay, option number D. So if you condense this C double bond O, see here you can see. So it forms C double bond O, then CH2. Okay, four times CH2 four times, then C double bond O, then comes NH, so it has a amide linkage, then comes CH2 six times, and then again NH. So this is the structure. So this is the structure of your nylon 66. So option number D is the correct answer. Okay, so we'll go for the next question. I hope this is clear. Okay. So natural rubber has. So what does natural rubber has? A alternate cis and trans configuration. B. Random cis and trans configuration. C. All cis configuration, and D. All trans configuration. Yes. So natural this natural rubber, it is made up of isoprene, and it is a cis. It is a cis polyisoprene. Okay, it is a cis polyisoprene. Okay, so option number C. So it is all a cis configuration. So option number C is the right answer. I hope this is clear. Okay, remember these things. Caprolactam is used for the manufacture of. So in what manufacturing caprolactam is used? A. Teflon, B. Terylene, C. Nylon 66, and D. Nylon 6. Yes. So where caprolactam is used? So caprolactam. Okay, the structure of caprolactam is like this, something like this. So it also has a amide linkage. So what it has? It has a amide linkage. It has a amide linkage. So this at 533 to 543 Kelvin. Okay, with water, it gives you what? C double bond O. Okay, CH2 5 times NH. Right. So C double bond O 1, 2, 3, 4, 5 times. So CH2 5 times and then NH. So this is the nylon 6. So this is nylon 6. So where it is used for manufacture of nylon. So caprolactam is a monomer which is used for the manufacture of the polymer which is nylon 6. Okay, so option number D is the right answer. I hope this is clear. So we'll go for the next one. Which of the following is an example of thermosetting polymer? Okay, so which is the example of thermosetting polymer? So we have discussed about what is thermosetting. So these are cross-linked or heavily branched molecules. So which on heating, okay, it undergoes cross-linking. They become hard. Okay, they become hard and they are infusible. That is, so they become hard, okay, and it is an insoluble mass. It is infusible, okay. It cannot be reused again and again. So, which is the example among the following of a of what? Of thermosetting polymer. Okay, so this is A, which is a structure. First one is neoprene. Okay, because Cl is there. Okay, there is a Cl. So Cl is what? When Cl is there, it is neoprene. Okay, when CH3 is there, it is isoprene. So it is neoprene. So neoprene rubber. Okay, neoprene rubber means it is a elastomer. So it is an example of elastomer. Okay, elastomer. Next, CH2, CHCl. So this is what? So this is used in making PVC. Okay, that is polyvinyl chloride. So this is a polyvinyl chloride. So this is what? It is a thermoplastic. It is a thermoplastic polymer. Okay, thermoplastic polymer. Next is what? It is nylon 66. Okay, it is a nylon 66. Nylon 66 is what? It is a fiber. It is a fiber. Next is what? Noveloc. Next is Noveloc. So Noveloc, what happens? They will undergo cross-linking to produce bakelite. So this will undergo cross-linking. Further, it undergoes cross-linking to produce what? Bakelite. To produce bakelite. This is an example of thermosetting polymer. Okay, thermosetting polymer. I hope this is clear. So option number D is an example of a thermosetting polymer. Okay, so we'll go for the next one. Which of the following organic compounds polymerizes to form the polyester dacron? A. Propylene and para. Okay, OH, C6H4OH. B. Benzoic acid and ethanol. C. Terephthalic acid and ethylene glycol. D. Benzoic acid and para OH, C6H4OH. Yes. So which of the following is used for polyester dacron? To produce dacron, okay, so to produce dacron, terephthalic acid and ethylene glycol are used. So ethylene glycol is what? CH2OH, okay, and uh, CH2 OH. So this is ethylene glycol, and the terephthalic acid is COOH, and this is COOH. Okay. So when you heat this, it produces Decron. It is O, CH2, CH2, O, then C double bond O, C double bond O. So this is the structure. Okay, so it produces the polyester Decron. Okay, so we'll go for the next one. Nylon is example of, so what is nylon example? It is example of polyamide. Okay, we have seen this. It has a amide linkage, so it is an example of polyamide. So this was a question asked in NEET 2013. Next is, which of the following is neoprene? Okay, neoprene structure we have seen. Which is the neoprene structure? It is A. CH2 double bond PCl CH double bond CH2. Okay, so this is chloroprene. Actually, this is chloroprene. So this chloroprene, it undergoes polymerization to give you neoprene. Okay. Which of the following is not a condensation polymerization? Yes, so melamine, glyptal, dacron, and neoprene. So neoprene. Okay, the answer is neoprene because neoprene is a addition polymer. Okay, as we have seen the type of polymerization, you can check. Neoprene is a addition polymerization. Which of the following statement is false? A. Artificial silk is derived from cellulose. B. Nylon 66 is example of elastomer. Then the repeat unit in natural rubber is isoprene. So this is a correct statement. Both starch and cellulose are polymers of glucose. Yes, this is also correct statement. So which is wrong? So nylon 66 we just saw, it is an example of not elastomer, it is of fiber. Okay, so it is correct. So the wrong statement among the following is nylon 66 is example of fiber and not of elastomer. Okay, so option number C. Option number C is the right answer. That is nylon 66 is the example of fiber and not of elastomer. Of the following, which of one is classified as polyester polymer? So which has a polyester bond, ester bond? Hmm? So which has a polyester bond? It is A, terylene. Okay. So it is made up of monomers like ethylene glycol, that is CH2OH, CH2OH plus ethylene glycol, terephthalic acid. Okay. When you heat it, it forms O, CH2, CH2, O, then C double bond O. Okay, so this is terylene. So this is the structure of terylene, which is also called as dacron. Okay, it is an example of polyester. Next one, which of the following structures represent neoprene polymer? Yes, now this question is correct. It is A. Okay, A is the structure of neoprene. So that question was misprinted. Okay, so this is the correct answer question. Next one, structures of some common polymers are given which is not correctly represented. So just see neoprene, the structure of neoprene, is it right? The structure of neoprene is CH2, C, Cl, double bond CH and CH2. So this is the structure of neoprene, right? So this is wrong. Terylene, just now we saw it, O, C. So this is correct. Nylon 6 is NaC, this is correct. Teflon is also correct. So option number A. So the correct which is not given is A. The structure which is not correct among the following. So we'll go for the next question. Which of the one of the following statement is not true? A. Buna-S is a copolymer of butadiene and styrene. Okay, so it is correct. Next one, natural rubber is a 1,4 polymer of isoprene. So this is also correct. Then in vulcanization, the formation of sulfur bridges between different chain makes rubber harder. This is also correct. Natural rubber has the trans configuration at every double bond. No, it has a stress transfiguration. So which is the answer, which is the statement which is not true. Okay, and which is the correct answer? It is option number D. So in natural rubber, it has all cis configuration. Okay, add double bond. Next, which one of the following polymer is prepared by condensation polymerization? So which is the polymer which is prepared by condensation polymerization? It is nylon 66. Okay, and natural rubber is prepared by addition polymerization. Teflon is also addition. Styrene is also addition polymerization. So the example of condensation means it is the condensation of bifunctional or trifunctional group with the elimination of small molecules. Okay, it undergoes condensation. So option number D. Next question. So NHCH2 6 NHCOCH2 4 CO is an example of, so what type of example is it? An example of homopolymer, or it is example of, so what is the example of? It is example of what? Yes, it is example of homopolymer, copolymer, addition polymer, or thermosetting polymer. So it is example of what? It is how it is formed. How this particular polymer is formed. It is formed by condensation of adipic acid and hexamethylene diamine. Okay, so it is a there consists of two different monomers. So it is example of copolymer. Okay, and it is made up of copolymer because it is made up of more than one type. It is made up of more than one type of monomer molecules. Okay, so it is called as copolymer. So option which is the correct answer? It is option number B. Okay, it is option number B. So option number B is the right answer. Okay, so option number B. Okay, so we'll mark the answer. So option number B. Okay, so it is B. Okay, so there was some slight process. So the option number B is the correct answer. So it is the example of copolymer. Next one, the monomer of the polymer is, so they've given a structure. You have to tell what is the monomer of the polymer. Okay. So So you can see from the structure which is the monomer, it is option number A. Right, so you can see here CH2 is there, C is there, then CH3, CH3 is there. So if such units, and again this unit is repeating, right? So the monomer is repeating. So it is A. A is the correct answer. So we'll go for the next question. Which one of the following is a chain growth polymer? A starch, B nucleic acid, C polystyrene, and D protein. So which is the example of nucleic acid? What do you mean by chain growth? Chain growth means what? It involves a series of reaction. Okay. So the reacting molecules will have either free radicals or ions. Okay, so that it undergoes a chain reaction. So it is always important so that there should be any double bond or any it should contain double bond. Okay, so the must condition is that it should contain a double bond. So for undergoing a chain growth polymer, that is a addition this, so polystyrene. Okay, polystyrene starch is a what you can say, it is a macromolecule. Okay, it is a step growth. Nucleic acid, the correct answer is polystyrene. Polystyrene is the correct answer. Option number D. So polystyrene is what? So benzene. Okay, it reacts with CH2, double bond CH2 gives you CH2, CH3. So this in the presence of Fe2O3 and Cr2O3 gives you styrene. Okay, so it will give you CH double bond CH2. So this will undergo polymerization with C6H5 CO twice O2. Okay, gives you styrene, polystyrene. So CH, CH2. So this is polystyrene. So it is an addition reaction or chain growth reaction. Next is acrylamide is hard, horny, and high melting material. Which of the following represents its structure? So which is the structure of acrylon? So the acrylon structure is, it is NCH2 CH, okay, and Cn. So this will undergo and it forms CH2 CH and Cn. So this is the structure. So option number A. So option number A. So acrylan is an addition polymer of acrylonitrile. So this is the structure of acrylonitrile. So how is this acrylonitrile prepared? Acrylonitrile is prepared. Okay, that is acrylan is prepared from acrylonitrile. So option number A is the structure of acrylan. Monomer of this is, so which is the monomer of the given structure? 23rd. Yes. So the monomer is 2-methyl propene. Okay, the structure is CH3 C CH3 double bond CH2. So it is 2-methyl propene. So it is 2-methyl propene. So 2-methyl propene is the correct structure. Okay, so this is the correct structure. Next one. Which of the following is not correctly matched? So which is not correctly matched among the following? So which is not correctly matched? So terylene. Okay, when we're talking about, so neoprene, it is made up of correct. It is made up of chloroprene, nylon 66, hexamethylene diamine, and adipic acid is there. This is also correct. Then terylene. Okay, terylene is made up of what? Ethylene glycol and uh, terephthalic acid. Okay, so which is not correctly matched. And PMMA. So here the structure should be, okay, here it should have a oxygen. So this is the correct answer. Okay, so it is not matched. Terephthalic acid, CH2OH, CH2OH, and plus UOH, UOH. So when you heat it, what it forms? So O, CH2, CH2O, then C double bond O, and C double bond O. Is it the same structure? No, this is missing. So this is the correct answer. Okay, option number. One more question. So CF2 double bond CF2 is a monomer of, it is a monomer of Teflon. Okay, this is tetrafluoroethene, that is TFE. Okay, so option number what? Option number A. Okay, Teflon. Fine. So we'll go for the next one. Which compound forms linear polymer due to hydrogen bonding? So which compound? So the dotted lines, okay, the dotted lines represent your what? Your represents your hydrogen bonding. So between these halogens, okay, the halogens like fluorine. So fluorine is highly electronegative. So hence it is a linear polymer. So due to high electronegativity value of fluorine atom, it forms effective hydrogen bonding. So CF between the F. Okay, so it is option number C. I hope this is clear. So because among the following, if you see the electronegativity of oxygen, chlorine, fluorine, and nitrogen, fluorine will have the most electronegativity. So it is option number C. Natural rubber is a polymer of, it is a polymer of what? It is a polymer of isoprene. So option number D. Okay, option number D is the right answer. So we'll go for the next question. Terylene is a condensation polymer of ethylene glycol and terephthalic acid. Okay, option number D. Which one of the following is used to make non-stick cookware? Very important. So which among the following is used for non-stick? It is polytetrafluoroethene. Okay, or Teflon. Or Teflon, it is a tough material. So it is resistance to heat and a bad conductor of electricity. So as it is bad conductor of electricity and it has a tough material and it has resistance to heat. Okay, it is used for coating the cook to make them so that it will not stick. Okay, not stick. So this coating is used. So it is option number B. Option number B. The bakelite is prepared by the reaction between phenol and formaldehyde. So option number A. Okay, if you go to see the monomers, so it is the monomer is phenol and formaldehyde. So option number A. The biodegradable polymer is, so which is the example of biodegradable polymer? It is nylon to nylon 6. Important, very important. So the biodegradable polymer is nylon to nylon 6. Next question. Which one of the following sets form the biodegradable polymer? So which is the following set which forms a biodegradable polymer? It is nylon to nylon 6, which is an alternative polyamide polymer of glycine and aminocaproic acid. Okay, and it is biodegradable. So the set, it is made up of what? It is made up of aminocaproic acid, okay, and glycine. So it is option number 2. So these are the structures. Okay. Okay. So by this we have completed the MCQs. Okay. By this we have completed the MCQs based on our chapter, that is polymers. So I hope your queries are clear. Okay. The chapter is clear. So that's it. So these were all the things, important things which we have to deal from this chapter. Okay. So if you have any doubts, you can ask me in the next session. So thank you. I hope all the doubts are clear. Okay. So we'll meet in the next class with the next topic. So thank you. Thank you, students. Have a good day.